Welcome to HelpYourMath.com. In this one, we're going to be dealing with square roots that have multiplication and division in them. Now, just like the previous video of addition and subtraction, we're going to use the same principles to break down square roots. And in this case, what we're looking at is ways to use those techniques to make our life a lot easier when we're simplifying these radicals. All right. Now, for the first one here, we have a division, which has multiplication in the numerator and division in the denominator. And so what we're going to do is we're going to try to simplify this as much as possible. And usually the best way to break these down is to try to find, when dealing with fractions, a common numerator and denominator to simplify this with. And so I'll just begin by mentioning one quick thing, and that's when we're dividing two radicands together. This could also be the product of the quotient of two radicands and one square root. And the reason I'm mentioning this is just for the case of 70 over 7, which when we divide 70 by 7 gives us 10. It's a good quick first step. However, what I'm going to do instead is use the other method of the product of 2, in which we have the factors of 2 which make a product, and we can separate those products into two different terms. And so for part A here, what I want to do is take the square root of 5 by the square root of 70 over the square root of 7 and factor the square root of 70 into the square root of 7 times 10. And so we have 5 times the square root of 7 times the square root of 10 over the square root of 7. And what happens here is the square root of 7s perfectly go away when they divide into 1. And what we're left with is square root of 5 times the square root of 10 over 1, which is just the square root of 5 by the square root of 10. When we multiply these two, we get the square root of 50. And the factors of 50 that has a perfect square is going to be 1 and 50, 2, 25, right? 3 doesn't make it, 4 doesn't make it, 5 does, 5 by 10. And that's the last set of factors, right? And the biggest perfect square in this list, 25, so 25 by 2. So we have 25 by radical 2. And this is just 5 radical 2's then. So that's our solution for part A. And there are other ways we could have did this, like if we just divided the 70 by 7, which gives us radical 5, and when we divide 70 by 7, we get radical 10 as well. So there's multiple ways you can go about doing this. However, find the best way for you to work it out. And in the case of what I was doing here, I chose division because it's easier to factor the 70 into 7 and 10, which we know 7 is a factor of 70. So technically it's the same exact step. As we see here, we have radical 5, radical 10 is what's left over. So they both take you the same direction. Okay? Let's move on to the next one. And in this case, in part B, we have a FOILing method which deals with square roots. And so here we have square root of 5 plus 3 and 2 radical 5s minus 1. What we're doing here is we're foiling. And so what I like to do when I FOIL is I like to ungroup these. So I'm going to take the first set and I'm going to split it into two terms. I have radical 5, positive 3. And I'm going to multiply it by what's in the parentheses on this side. So we have 2 radical 5s minus 1, 2 radical 5s minus 1. This makes it a lot easier for you to do the distribution of what you're multiplying. When you have a radicand and it has no coefficient in the front, you can add the 1. So what we do is we multiply the outside numbers together first. 1 by 2 is just 2. And radical 5 by radical 5 is radical 25. Then we do the same thing out here. Since this has no square root, we're just going to do the 1 by the negative 1, which is negative 1. And the radical 5 comes along for the trip. For the next set, we have 3 by 2 radical 5. So again, we do the outside number with the outside number is 6. And the radical 5 is the term. 6 radical 5s when we multiply. And then we have 3 by negative 1, which is just negative 3. Now we're going to add like terms up, right? First we're going to simplify this operation. So we have 2, the square root of 25 is 5, minus 1 radical 5, plus 6 radical 5s, minus 3. And what we're doing is we're looking for like terms, so this becomes 10, minus 1 radical 5 plus 6 radical 5s, minus 3. And the 10 and the negative 3 combine. These are going to give us 7, right? 10 minus 3 is 7. And finally, we have negative 1 radical 5 plus 6 radical 5s. They're the same object, right? And so we're adding the coefficients. We have 6 and negative 1 give us positive 5 radical 5s. And this is basically the method we want to use when we're multiplying. If there's no constant outside of the radicand, when multiplying, we want to multiply that by a number we just put. Like in the case there's no number outside of these two, we can add a 1. So we can see that that's what we're multiplying by. So let's take a look at part C here. We have 2 radical 3's, and again, inside the parentheses there's a radical 2, so we'll put 1 radical 2 plus 1 radical 3. And we're going to distribute this to each term by multiplying the outside with the outside and the inside by the inside. 2 by 1 is just 2. Square root of 3 by the square root of 2 is the square root of 6 when we multiply 3 by 2. For the second set here, we do 2 by the 1 outside is just 2. And the square root of 3 and the square root of 3, we multiply the insides. That gives us a square root of 9. So then we have 2 radical 6's plus 9 is a perfect square, so this becomes 3 when we take the square root of it. And finally, we have 2 radical 6's plus 6. And usually the radicand goes second. So in case this isn't the solution you see on a multiple choice, you can also write this as 6 plus 2 radical 6's. Either one of these answers are the same. All right? Make sure you understand that the irrational number, which is the square root, goes second in most cases, okay? And here we have part D, which is similar to the first part A in this. And what we're looking at is the square root of 30 over the square root of 2 divided by the square root of 5. Again, we want to factor 30 because 30 has a factor of 5. We're going to split this square root into 2 pieces. So the square root of 30, right, because the factors of 30 that have a 5 involved, so we could simplify this perfect, are radical 5 and radical 6 times radical 2 over radical 5. And these radical 5s are perfectly common. And they reduce to perfectly 1. And we're left with the square root of 6 times square root of 2. This becomes the square root of 12 when we multiply the insides together. And the factors of 12, we have 1 and 12. We have 2 and 6. We have 3 and 4. The only perfect square on this list is 4. And so we take this line to break down this radical 12, which is radical 4 by radical 3. Put in the perfect square first. And this just becomes 2 square root of 3's. Thank you.